Hi, so today we're gonna focus on first order differential equation. So here we're gonna do the linear equation. That's our first example. So the linear equation that we have on the screen, the first thing that you do, you change let 1 over cos. So 1 over tan x equals to cot x. So you have to change that to cot x. Then the formula that I wrote here on the top right here, that's the formula that we're gonna use for linear differential equation. So we're gonna go ahead and say dy over dx. We make dy over dx, then we put that y to the other side. Then you've got cot x equals to 3e sine x. So basically, we are trying to make this question similar to that equation right there. So we are trying to make it similar to that. So as you can see, here you've got negative, but then the formula tells you that you must have a positive there. So you're going to say dy over dx plus y open bracket minus cot x. So you must make it similar to that. You've got 3e sine x. So here, there is your p, then there is your y, and then obviously this one will be your q. Then now, as you can see, this equation looks similar to that one of the formula. So once you get to that point, that's when you can substitute. That's when you can substitute those values here. You can now proceed basically to this equation. So after writing that dy over dx plus y into minus cot x equals to 3e sine x, then you can proceed to that equation. The second step is to substitute whatever values you have on that equation. So that equation tells you that you must first find p integration of p dx, because all the other values you have them. You have got q, but you don't have this p dx. So we're gonna say p dx equals to, you know your p. I told you that your p is minus cot x dx. And then you're gonna have to integrate this cot x. If you go to your table of integral, you will see that cot x gives you minus ln sine x. The minus, it's originally from here. That's where the minus comes from. Okay. Then after doing this, you can go and substitute your values. So you've got e to the power minus into minus ln sine x. Okay. Then you say the integral of q. What is your q? Your q is 3e sine x. And then dx. Oh, sorry, I forgot to say multiply by e to the power integral of p dx. What is our p dx? You know that it's minus ln sine x dx right there. Then you just say plus c. Guys, as you can see, here you have got negative ln sine x. Negative ln sine x. If you still remember your logarithmic rules, log rules, you can simply write this as this negative 1 there. You have to take it to the other side. So that's what we did there. Okay, that's what we did. So once you get to this point, you can simply You can simplify this equation. Let's simplify that. So to simplify this, you know that ln and e will always cancel. So you're gonna have sine x there. Ln and e always cancel. Whenever you've got e to the power ln, it will cancel. Or ln multiplied by e, it will cancel. So let's say open bracket, you've got 3e sine x multiplied by, I told you that you must take that minus to the other side. So you're gonna have e ln sine to the power 1 x dx plus c. Okay, then the only part that we need to solve is this one. To solve that part, you see there you've got e and ln. So the e and ln will cancel for here. Okay, let's proceed to the next slide. You've got y equals to sine x integral of 3e sine x multiply by, remember I said the e and the ln will cancel, so you're going to be left with sine to the power minus 1 x dx plus c. So this is the same as 1 over sine x. So we can put 1 over sine x there. We can put 1 over sine x to make this simpler. So let's go and remove the brackets. So to remove the brackets, we're going to multiply everything that is inside the brackets by sine x. So basically we're going to multiply the c with sine x, and then we're going to multiply this whole thing with sine x. Okay, let's do that. Let's do that. So it's the integral of 3e sine x multiplied by 1 over sine x. I said you multiply everything by sine x. Then you're gonna say dx there. Then you say plus c sine x. That sine x is there. The one that I've just highlighted in blue is the sine x that was outside. We multiplied everything with that. So your final answer will be 3e sine x. This one and this one will cancel. Then you're gonna say dx there plus c sine x. And then now, as you can see, the next step is to integrate this. Then you are done. The next step is to integrate this. Then you are done. So the integration of 3e to the power sine x dx will be equals to, so remember, if you want to integrate this from your table of integral, you will see that integration of e to the power f of x will give you e f of x over the f prime of x. That's what we're gonna do there. So in this case, our f of x from this equation right here, the one that I just wrote, the f of x in this case will be equals to sine x. So it will be equals to sine x. That's our f of x. And then you need to know from that very same derivative table. In most cases, you don't have from the integral table, you don't have the derivative table. So our f of x, if it's sine x, the f prime of that, you need to find the f prime, because the formula tells you that here you need the f prime and the f of x to solve that equation. So the f prime of this, you'll get cos. If you use the derivative table, you'll see that the derivative of sine, you'll get cos. So let's go ahead and substitute back to the original formula. You've got 3e f of x. Instead of sine, you write f of x. Then your answer, your dy over the derivative of this will give you 3e. What is your f of x? Sine x over cos x. Then this we can now write our final answer. So your final answer, you'll just add that plus c sine x. Then this will be your final answer. This will be your final answer. You just add that from the previous slide. Remember what we're doing. We're just solving this part here. We're just solving this part. And then it had plus c sine x there. Okay. Then here, okay. So if you need the online sessions or tutorials, you can contact me on this number for Maths 1, 2, 3 and Maths N1 to N6 and also the engineering mechanics. You can just contact me. Also, if you've got a question, you can contact me as well and ask the question. I'll leave the WhatsApp link below. Okay, let's do the exact differential equation. So the exact differential equation, how do you know that it's exact differential equation? The exact differential equation, this is the formula, the standard formula there on the top right. I wrote the formula on the top right. So the functions are mixed inside. You see, you check your dx there, you check your dy. See, so the functions inside the dx, they are mixed. There's x and y functions. So that's when you know that it's exact differential equation. So you need to check whether the two are exact or what. So the first thing that you do, you're gonna let this one be your m, this one be your n. Okay, so let's write that down. M equals to 8xy plus 2y. So this, guys, you cannot integrate this because it's mixed inside the dx. It's a mixed function. So then your n, remember they said it's m plus n equals to 0 from the original equation. Your n, look at this, it's a negative there and it must be positive. So you're gonna say negative into negative 4x squared minus 2x. To make it positive here, you need to do this. So your n will be, you remove the brackets now, you multiply everything with negative, so you're gonna have positive 2x. That's when your n will be positive. So now if you put that n back to the original equation, you're gonna have positive there in between. Okay, so after doing this, then you can differentiate. Before you integrate, you differentiate. So the reason why we are differentiating, we want to check if m is equals to n. You check first. For such questions, you check if it's exact or not. So m must be equals to n to show that the equation is exact. So n must be equals to m. So there you have it. Let's write that down. Your m was equals to 8xy plus 2y plus 2y. And then your n was equals to 4x squared plus 2x. And then look at this, guys. If here you had dx for your m. If you had dx, to check that it's exact, you're gonna do the opposite when you differentiate. So since there you have got dx, in this case you're gonna say dm over dy when you differentiate, because here you had dx, so you do the opposite of that. If you had dx, I repeat, let's go here. Just because your m had dx here, when you differentiate with respect to y. You don't do the dy, the dx I mean. You say dy, you do the opposite of that dx there. So if you had dy, you do dx. You see here you had dy. So for your n, you're gonna say dn over dx. So let's differentiate that. So the differentiation of 8xy with respect to y, you're gonna get 8x. And then the differentiation of 2y, you're gonna get plus 2. Then let's go to the n side. The n side, we are differentiating with respect to x. So the differentiation of 4x squared, you're gonna get 8x. Then the differentiation of 2x, you're gonna get 2. So to conclude, you say n is equals to m. So nb, since n is equals to m, then you can do direct integration. So when I say direct integration, I'm gonna duplicate this. Slide. When I say direct integration, guys, I mean that you go back to the original equation, your m and n from the original equation. You go back to the original equation. Since they are equal, only you do this only if they are equal. Only if m and n are equal. So you first check if they are direct, they are exact. Then if they are exact, that's when you can integrate. So since they are equal, since n is equals to m, then you do direct integration. So what I mean by direct integration, you're gonna say m is equals to, you're gonna integrate that equation. Remember, originally it had dx. That's when you consider the x now. You don't do the opposite now. You consider it as it is. That's why they call it direct. Direct means there's no change. You're not changing anything. So the integration of this with respect to x, you see here, dx tells you that you have to only focus on the x functions. So 8y, in this case, is going to be a constant. So when you integrate that, you're going to treat 8y as a constant. Let me write 8y. 8y is a constant. You only focus on x. So you're going to get 8x squared over 2. And then plus, you're going to focus. You see there, you've got 2y. But you don't want y. You only want the x functions. So you're going to treat 2y. You're going to treat 2y as a constant. Then since you're integrating with respect to x, you're going to put x there. Let's go to the n side. The integration of 4x squared plus 2x dy. Guys, please understand this. That 2y is a constant. So when you integrate a constant, it's like you're integrating 2. What is the integration of 2 with respect to x? You're going to get 2x. So here you've got 2y because that 2y is a constant. You multiply it with that x. You're going to do the same here. For n, you're going to get the integration of n. Now we are integrating with respect to y. So we're going to treat the x functions as a constant. So that 4x squared is a constant. Then you just put y there. Then you say plus the 2x, it's a constant, so you just say 2xy. Then after doing this, for your m, you're gonna get 4xy squared, sorry, 4x squared y plus 2xy. Then now for your final answer, guys, you're gonna say m plus n equals to 0. So you're gonna say put your values. So you don't repeat, guys, you only put, like for instance, you see that your m and n, after integrating, they're equal. You don't add them because the functions are repeating. You just write 1. If you repeat them, they will add, and then you'll have 8x squared y. So you don't add them. If the functions, you compare the two functions, compare the values, basically, rather, you compare this n and m values that you found. So if they are equal, you just write it once. You don't repeat it. You write it once. So you're gonna write it once. You're gonna say 4x squared y plus 2x 2xy is equals to 0. Then that's your final answer there. If you've got any question, please comment or DM me. Okay, now let's move to Bernoulli equation. Bernoulli, it's a bit different from the previous equations. Okay, so here you have it, Bernoulli. So the Bernoulli equation that we have here, it's already simplified. It's already simplified. So I wrote all the formulas on the top right there. I wrote all the formulas. So this formula, you're gonna have to identify your P, your Y, and your Q. So in this case, our Q is this one. There's our Q. And then our P is there. So our P equals to 1. Okay, P equals to 1. And then your YN in this case, it's gonna be this one. You see the YN, that's your YN. The reason why is this YN is because originally this equation, before they derived this equation, it was like this: plus y to the power minus 2 over y minus 3. So basically what I'm trying to do here, I'm trying to make it similar to this formula. I'm gonna highlight it in green. I'm trying to make it similar to this formula, the first formula. That's how they derived it. It was like this originally: 3x y to the power 3. That's how the formula was like. So that's why I'm saying this one is your n there. That's your n. So they divided everything by n. You divide everything by y to the power n because you need equation that has got q that side. So that's how you derive it. So that one is already solved. You divide everything by y to the power n. Okay. So after identifying your values, that this one is q, this one is y to the power n, the next step, you say z equals to y. The y that you're gonna take this value that is in front of p. Remember I said p is equals to 1. P is that one that is in front of that y there. So the value that you're gonna put there is this one. So you're gonna say z equals to y to the power minus 2 always. And then now you can differentiate. You can say dz over dx. You differentiate with respect to x, so you're gonna say differentiation of y to the power minus 2, and I get minus 2 y to the power minus 2 minus 1. Then just multiply it with dy over dx there. And then your final answer will be dz over dx equals to minus 2y minus 3 dy over dx. So once you get to this point, look at your equation, your original equation. You see your original equation had dy over dx. So this simply means that from this equation you have to make that dy over dx the subject of the formula. You have to make it the subject of the formula, so you're gonna have to derive it. So dy over dx will be equals to make that dy over dx the subject of the formula, we need to get rid of minus 2y to the power minus 3. We need to get rid of that. So you're gonna get dz over dx. If you divide everywhere by minus 2 over 3, so you're gonna get 1 over minus 2y to the power minus 3. So that's how you derive it. You make dy over dx the subject of the formula. So you need to get rid of that minus 2y to the power minus 3. And that's what you did. So that dy that we found here, we're going to have to substitute it back to the original formula. Then let's do that. So from the original formula, when you substitute those values, let me remove this. We don't need it for now. So when you substitute this to the original formula had y to the power minus 3. Then where there is dy over dx, you're going to put this dz over dx. So you're going to put dz over dx. Then it was multiplied by minus 1 over 2 y to the power minus 3. Then you say plus. You see there, we said y to the power minus 2 is equals to z. So instead of writing y to the power minus 2, you can write z. You can substitute the z there. Equals to, what was it equals to? It was equals to 3x. So this z that you see here replaces y to the power minus 2 from the original equation. Remember we said let z equals to y to the power minus 2. Then yeah. So when you multiply out this and this will cancel. And then you're going to be left with dz over dx into minus 1 over 2 plus z equals to 3x. So look at this, guys. We still have another problem. We need to get rid of that because we are looking for a standard formula. So you have to multiply everything by minus 2 to get rid of that. So everything that is inside the brackets there, you multiply both sides by minus 2. You multiply by minus 2 there. You multiply by minus 2 on both sides. So the minus 2 here, it multiplies this and then it also multiplies the z. So you're gonna get dz over dx minus 2. Let me write z with a different color. Multiply by z equals to minus 6x. And then this formula, guys, if you remember from the linear equation, you had dy over dx from the linear equation plus p y equals to q. So basically the reason why we're solving this, we wanted to make it this equation similar to this one. So now look at this, we have a problem here. That minus 2, it must be positive, so that this minus 2 will be our p, and then this one will be our y, this one will be our q. So we need to get rid of that minus there. Okay. So in order for you to get rid of that minus, this is what we're gonna do. To get rid of that minus, you're gonna say dz over dx. You say plus into minus 2. Then you put that z there. Then you say equals to minus 6x. Then now we can apply that formula. Now we can apply the formula. So since we got to this point, we can use this formula. Remember the linear equation. The linear equation tells you that if this one is your p, then this one is your y, then this one is your q, then you can use this formula. That's the formula that we used previously. So in this case, since you are using the functions of z and not y, we don't have dy over dx here. Rather, we have got dz over dx. So from our equation, we're going to write z equals to, you see there, from that equation, the equation tells you that you need to find p dx first. So we can write p dx equals to, what is your p? Your p is minus 2. So you can find the integration of minus 2. So the integration of minus 2, you're going to get minus 2x. That's the integration of x of minus 2. So you're going to get minus 2x. So going back to original equation, you're going to say e to the power minus into minus 2x. Okay, minus 2x. Minus 2x. So here you can put 2x. This one right here, it comes here. It's that p dx. And then we're going to say open bracket, integration of q. Our q is minus 6x. And then multiply by e to the power, integration of p dx. So our p dx is minus 2x. Then dx plus c there. And then your z will be equals to e to the power 2x into integration of minus 6x e to the power minus 2x dx plus c. Then let's proceed to the next step. So the next step, you're going to have to remove the brackets. So the next step is to remove the brackets. So let's write that equation, e to the power 2x integral of minus 6x multiplied by e to the power minus 2x dx plus c. So the next step is to remove the brackets. So we're going to multiply everything with that. So even the c and also that equation, and I multiply it with e to the power 2x. So let's go ahead and remove the bracket. That will be equals to e 2x multiplied by e to the power minus 2x integral of minus 6x dx plus e 2x multiplied by c. So z will be equals to, remember here, you're multiplying the powers of the same base. You subtract the exponent, so you're going to have e to the power 0 there. Integral of minus 6x. So what is the integration of minus 6x? You're going to get minus 6x squared over 2. Then you say plus e 2x times c. Okay, then your final answer will be minus 3x squared plus e 2x multiplied by c. Then that's your final answer. Obviously, since you know that z from the previous slides, z was equals to y to the power minus 2. So you can replace z with y to the power minus 2 to make the equation linear. X squared plus c e 2x multiplied by c. Then that's your final answer. Substitute this z, guys. Substitute that value there to make it the proper equation. Okay, guys, that's all for the day. If you've got any question or any queries, or you need online sessions, one-on-one or group sessions, please contact me. And then for more updates, please subscribe to the YouTube channel. Then I'll put more videos for this subject. Thank you for watching.